Hi, welcome to Chapter 11. We're going to talk about inheritance. And so this is basically taking objects and kind of like going further with them. So let's first talk about what inheritance is. We're going to talk about inheritance. We're also going to talk about a thing called polymorphism. So inheritance, in the real world, many objects are specialized in versions more general objects. For example, grasshoppers and bees are both specialist types of insects. In addition to general insect characteristics, they also have unique characteristics. Grasshoppers can jump, bees can sting, make honey, and build hives. So they both are insects. They have 6 legs, a thorax, and all the best parts of an insect. But a grasshopper has those big long legs, and they basically can hop, where a bee has wings, has a stinger, and they basically live in a hive and make honey. So this is kind of what that's talking about. So we have our insects. So think about classes. We talked about classes and object orientation. So now let's take that class. We have an insect class. So let's make a class from the insect class, but call it Bumblebee. So it's going to have all the general characteristics of an insect, but the Bumblebee class is going to take all those general and actually add some more to it. Same way with the grasshopper. They both start with the insect class, which has the basic insect characteristics, and then they add what characters they need for that particular object. And so what they call this is a relationship. Okay? For example, a grasshopper is an insect. A bee is an insect. A rectangle is a shape. A daisy is a flower. So we could have a flower class, and then we could have a daisy class that inherits from the flower class, or whatever type of flower it is. So when we talk about the is a relationship, we're talking about the inheritance between what's called a superclass. That's the class like the insect class, and then a subclass, which is called the like say the bumblebee or the grasshopper. So another nickname for the superclass is called the base class, and the derived class is the nickname for the subclass. The subclass inherits everything from the superclass, so it has everything the superclass has, plus it's going to have a little bit more for what it needs. So we're going to get into some examples here. So we have automobiles, and inside the automobiles we have cars, pickup trucks, and SUVs. All automobiles are going to have a make, a year, a model, mileage, and a price. This can be the attribute for all of the classes. But a car also has number of doors. A pickup truck has drive type, whether it's 4-wheel drive or 2-wheel drive. An SUV has passenger capacity, how many people can fit in that particular item. So let's go ahead and take a look at that. So I'm going to be over on page 585, and we're going to talk about the automobile class, which is I believe it is the vehicles. So here's vehicles, and let's take a look at the class itself. So it's a class. So we've got automobile, and here is our init program. Remember, this is the 2 underscores in front and behind make this private, meaning only this class can see it. Itself is the object itself that's basically creating here. And we're going to have make, model, mileage, and price. So when we initialize this class, we need to make sure that we do supply a make, model, mileage, and class. And then we've got our underscore make, model, mileage, and price, which are all private. They're hidden just to this particular class. We're going to make it equal to the make, model, and mileage, and price. We have our 4 setters, and we have our 4 getters. So we're going to allow the folks who use this class to change each one of those data instances, and we're also going to allow them to get each one of those data instances, but they do not have direct access to those because they are private. Okay. So what we've done here at the bottom now is we've now created a class called car. But notice inside the parentheses it has automobile. That means that car inherits everything from automobile. So all of those getters and setters automatically come with it. And here is our init program. And notice we've got make, model, mileage, price, and now we have doors. So we're going to, notice it says automobile.init. So it's basically saying inherit everything from automobile, and also we're going to get make, model, mileage, and price. And we're going to also have this private doors equal to doors. So automobile gets our make, model, mileage, and price. We also added doors. So when make comes in, it's going to go down here to the init for automobile, same way with model, mileage, and price. But doors is going to be put into this new added data instance to the car. We've got a set and a get for the doors, because remember the setters and getters from automobile automatically come as well. So now let's take a look at the class truck. So truck says I'm going to inherit everything from automobile, and it's going to have make, model, mileage, and price. So that comes with the automobile. And then we have drive type. So same thing here. I'm saying automobile.init. We're going to make that equal to the make, model, mileage, and price. And then this new data instance that we've created just for the truck class is going to inherit, or going to basically get the drive type imported. So basically, it's going to have that as a parameter being brought in. So when we create an instance of a truck, we need to make sure we pass make, model, mileage, price, and drive type. Now notice we have our setter and our getter for drive type. The last thing we have is SUV. So we've got our SUV class. It's got automobile, and again we got our init. And this time we're going to have make, model, mileage, and price. Again, those come with the automobile. And we've got a new one called PassCap, which is passenger capacity. And again, our automobile.init, that lets us initialize the make, model, mileage, and price. And then we've got a new field, PassCap, and we have our set and our get for each one of those variables. So the whole point of this is to let you know that, hey, I want to create a truck class, but I don't have to recreate all of the fields. So I'm going to inherit from the automobile, so I get everything the automobile has, all the getters and setters, the init, everything. But then I'm going to add one more, which is called drive type. Now, since those aren't in automobile, I have to deal with those separately by by initializing that, and then having its own getter and setter for that as well. So let's see how we use this. So now we're going to have our car demo. And notice the very first thing I do is I say import vehicles. So that automatically gets brought in. So I'm going to say used car is equal to vehicles.car. So this says, hey, we're going to use the file vehicles, and we're going to basically create an object from the car class. And in here we've got our make, model, mileage, price, and then doors is equal to 4. So now it's going to use everything the vehicles class has, but it's also going to have doors. So we're going to basically, so now, since we're using vehicles.car, again, it's got everything the automobile has, but car also has a number of doors. And then we're going to say print. Make is usedcar.getMake. Model is usedcar.getModel. So here's our getters right here. So it's going to be get make, get model, get mileage, get price, and get doors. So when we run this, there it is. Make is Audi, model is 2007, mileage is 12,500, price is 21,500, number of doors is 4. So inheritance, a really nice feature to have. It allows us to not recreate things. One of the examples that I had in one of my textbooks is, let's say you manufacture watches, and you have your basic watch that has a minute hand, an hour hand, and it's got all the numerals on the dial. Okay, it's just got a regular plastic or rubber strap. Well, you want to create a new watch, but you want to start with the basic. So you start with the basic, And this time you're going to add a second hand. This time you're going to have the numbers as Roman numerals. Maybe the hour hand and minute hand are going to be glow in the dark so you can see them at night. Those types of things. You might have that little second hand dial on the inside. So you start with the base model of the watch, and then we're going to add to it to make it more, a more extravagant watch, something that costs a little bit more money. Okay. Now, back to our PowerPoint. So basically, again, we got our automobiles. We talked about the car, pickup truck, and SUV. And again, the car class is a subclass of automobile because we're starting with automobile, but we're creating a car class from it. Okay. Now, we talked about the UML diagrams, the universal markup language. How does that look when we talk about inheritance? Well, here's the automobile class, and here's the 4 data instances, and then here is all of our methods that we have inside of there. Here's our initialize, set, get, so our setters and getters. So there's the superclass. Now notice the arrow goes up to the automobile. That says that each one of these inherits from the automobile. So the car also has doors. Remember, it's got everything automobile has, and it's got a new init that basically has the make, model, mileage, price, and doors, and then so it's got the doors in there as well. And then we got our set doors and get doors. Same way with truck. We've got the drive type, new data instance, and here's a new init. It's got the make, model, mileage, price, and drive type. And then we've got set drive type and the get drive type. Same thing with the SUV. So basically everything that's up here is also included down here, but we don't retype it. There's no need to retype it because when we inherit from it, it automatically brings that stuff in. Okay, so on page 593 on to 594, 95 is in the spotlight, and we talk about accounts. So if I look at accounts, here I've got my class savings account, and here's my net. We've got account num, interest rate, and balance, and we create our 3 data, our hidden variables. We've got our 3 setters, we've got our 3 getters. Okay. Down here now I have a class CD that inherits everything from savings accounts. Everything up above is also included down below. Here's our new init where it's got account num, interest rate, balance, and mat date. And so we're going to say, okay, let's initialize everything from savings account, which is those 3, and then we're going to basically also include maturity date, which is mat date. And then we include our set and our getter for maturity date. Okay, so now how do we use this? So let's look at account demo. And first thing you notice, we import accounts. And then we've got our main, which is, we're going to say enter the following data for the savings account, input account number, input the interest rate, input the balance. And then we go ahead and create our object. This is our savings object, which is created from the savings account class that's inside of the accounts file. And we pass in the account num, interest rate, and balance. And then we're going to say, let's enter the following data for a CD. So we get the account number, interest rate, balance, and maturity date. And this time we're going to create a CD object from the CD class that's inside of accounts. We got account num, interest rate, balance, and maturity. And then we're going to say, okay, here's what you've entered. Here's your savings account, account number, interest rate, balance. Your CD is account number, interest rate, balance, and maturity date. So let's run this and see what it looks like. So here's our account number. Our interest rate we'll say is 5%. The balance we'll say is 5,000. And the CD, let's say that is that. Our interest rate is 4%. Our balance is 6,000. And the maturity date is 12/21/2027. And there it comes back and says, okay, your savings account displays that information. Our CD, it displays that information. Now, can I use maturity date for my savings account? I'm going to say no, you can't, because if we look at the accounts, savings, the class savings account does not have a maturity date. So if you try to use maturity date, you will get an error. Now, one thing I did is we do have a cars, truck, SUV demo. Now, here's what I like to do with my imports. Again, you have 2 extra lines, but I say from car, import car. From truck, import truck. And from SUV, import SUV. So we've got an SUV, truck, and a car class. And if we look at the truck, it says from vehicles to, so I created a vehicles to. You don't have access to that. I created it. I'm trying to show an example. And so vehicles to is just the automobile class. Okay, it has the make, model, mileage, and price. So the truck class, from the vehicles to file, import automobile. So then I just say class truck automobile, and then I say automobile done. So it does everything. So that way there, I don't have to say vehicles to dot automobile. I can just say automobile. So again, I kind of like the looks of this, or it works a lot better as far as, again, it's whatever you want to use. If you want to use, because like I said, when we get to the truck demo, the car, truck, SUV demo, I have to type in 3 lines as opposed to just saying import automobile. So here I create a car. It is from a car class. There it is. A truck is from the truck class. There it is. SUV is from the SUV class. And then we go ahead and print the inventory. Notice that for car, it's got doors. For truck, it's got drive type. And for SUV, it has passenger capacity. So there's no drive type or passenger capacity for car. And for truck, there's no doors or passenger capacity. And for SUV, there's no drive type or doors. So if we run this, there it is. So there is the car, and the following cars in inventory: BMW 2001, 70,000 miles, $15,000, number of doors 4. The following pickup truck is in inventory: Toyota 2002, $40,000 or 40,000 miles, $12,000, and it's 4-wheel drive. Following SUV is in inventory: Volvo, model is 2000, mileage is 30,000, price is 18,500, the passenger capacity is 5. So, inheritance, a great way to create a class from another class and then add some stuff that you need specific to that. So think of the inset class. We might have an inset class that talks about number of legs. It's got a body and a thorax and a head and whatever other features or antenna. Okay, those are all part of the inset. Well, then I might create a B class from the inset class where I'm going to add wings and a stinger and hairy stuff on their legs to basically pick up pollen, and they're able to make honey. We might make a grasshopper class from the insect class where now it has those big hind legs. It's got some different features, whatever different features it needs, we can add those and then have its own getters and setters. Okay, so when we create a class from another class, do we have to keep everything the same as far as the methods? So, for example, mileage, do we have to keep it as whatever it brings back, do we have to keep that? No, we don't. We can change that through a process called polymorphism. So the object's ability to take on different forms. So the essential ingredients of polymorphic in behavior is to define a method in a superclass and then override that in a subclass. So again, whatever that method does in the superclass, it doesn't have to, we have to keep the name of the method, but what that method does can be changed. We can call the correct version of an override method depending on the type of object that called for it. Okay, so we'll get that more, and there's more. We'll get more details in just a second in their example. In the previous inheritance example, showed how to override the init method. So notice how we overrode the init method by adding that extra step that was basically brought in. For example, a number of doors, drive type. Called the superclass init method and then added on to that. The same can be done for any method. The method can call the superclass equivalent and then add to it or do something completely different. So let's go ahead and take a look at the example, and let's take a look at the animals class. So here is the class mammal. So we've got our init, which is species, and then here we basically load the data instance of species. We've got our show species, and we've got our make sound. And the sound is grr, and it says I am a species. It's going to say whatever species it is. So when we say show species, it will basically show whatever is in the data instance species. Now, so now we have a dog class. It inherits from the mammal class, and here's our init, and it says species is equal to dog. Okay, up here species is going to be brought in whatever is basically passed into on when it's initialized, or when an instance of that variable is created, or that instance of that object is created, when it's instantiated, whatever species is basically passed in, that's what's in there. But with the dog, we go ahead and make the species equal to dog. Now, by the way, this species colon, that's only there when it is for this PyCharm. If I were to comment that line out, you'd see that goes away. Okay, just realize that's only there. It's kind of a helpful little hint within PyCharm. Okay, now notice here we got make sound, and look what we did. Now it says print woof woof. It's no longer grr, so we overrode, that's called overriding, we overrode the make sound in the mammal class. Now we have a cat class which inherits from mammal. This time we're going to make the species equal to cat. And notice that we overrode the make sound to say meow. So we overrode it. So there's the polymorphism. Poly means many and morphism means change. So it's many, many changes you can make to that particular superclass. Okay. It's the let's see, animals. So yeah, it's the polymorphism demo. So we look at that, and here we create mammal is equal to mammal, regular animal. Dog is equal to dog. Notice I said from animals import, and there they just basically do it import mammal. But I like to use the from in the import class. So here I just say mammal I'm going to create a mammal class. I'm going to create a dog object from the dog class. I'm going to create a cat object from the cat class. And it says print, here are some animals and sounds they make. Show mammal info mammal. Show mammal info dog. So we've got this show mammal info down here, so we pass in the mammal object. So here's the mammal object being passed in. We're going to say creature.showSpecies and creature.makeSound. Then we say show mammal info dog, so it's going to pass the dog class or dog object down here, and we're going to say creature.showSpecies, so show the dog, creature makes sound, and it's going to basically do the woof woof. Then we basically show mammal info cat. We're going to pass the cat object, so the cat comes in, so creature.showSpecies, it's going to display cat, creature makes sound, it's going to basically print meow. So let's see how that looks. So there it is. I'm a regular animal, grr. I'm a dog, woof woof. I'm a cat, meow. Let's take a look at the polymorphism demo 2. Well, let's look at wrong type. I'm sorry, let's look at wrong type. So this one here says, show mammal info, I am a string. Now, if we look at the polymorphism demo, notice that when I say creature, when I say show mammal info, mammal, down here, if I were to say show mammal info, I am a string, what is that method expecting to see? So here's show mammal info creature. It's expecting an object. It's passing in text. So what happens if I were to try to do that? So I'm going to copy this. I'm going to paste it into show polymorphism right down here. I'm going to say show mammal info, I am a string. When I run this, watch what happens. Up here, we get an attribute error because it goes, hey, I'm expecting an object to be passed in, but instead, you passed in a string. Okay? I don't know what to do with that. So we get an attribute error. So what we can do instead is, with our polymorphism demo 2, we've got show mammal info mammal, show mammal info dog, show mammal info cat. So nothing's changed so far, except now we've got show mammal info, I am a string. So now notice when we come down here, show mammal info creature, it says if is instance creature, comma, animals.mammal. So what it's saying is, if you are for this item that's been passed in, if you are an instance of the animals file mammal class, so if you're an instance of that mammal class, we're going to go ahead and say creature.showSpecies and creature.makeSound. If it's not an instance of, we are going to print that is not a mammal. So the object that's passed in to creature, we're going to say, is that an instance of the mammal class? And that's basically what this is saying right here. The polymorphism provides great flexibility when designing programs, just as we saw. We don't have to use the same guts of a method that is the superclass. We can change the guts of that method to something else. We have to keep the method name the same, though. We can't have it, so if we try to pass in something to a particular method that doesn't have the same attributes, we will get an attribute error exception. To get over that, to make sure we never have that issue, we can do an instance of method, which is a function that's built in to classes, and determine where the object is an instance of. For example, instance of, and we're going to take the object that we are trying to compare and see if this object is an instance of this class. Okay, I think, have we covered everything? I think we have. Yeah. So this chapter covered inheritance, including the is-of relationship. Is a car a vehicle? Is a truck a vehicle? Is a SUV a vehicle? Is a dog a mammal? Is a cat a mammal? We define subclasses and their initializer methods. So we showed how we can create a new class that's a subclass of a superclass, and then we can actually add things to the initializer. Polymorphism, we can check to see, we can actually create a subclass of a superclass and then change the guts of the methods to basically properly fit that particular new class. We can also use the isInstance function to see if something truly is the instance of a superclass. Okay, kind of a short chapter. Again, if you have any questions at all, give me a call. We can Zoom, we can do whatever we need to do, and I can help you through any issues that you're having. We'll see you next chapter.